Hello again everyone, welcome back to ptet.chemistry channel. So this is the first of these tutorial questions on the multiple choice questions involving general periodicity. So 9.1 that refers to general periodicity. So which of the following oxide is unlikely to dissolve in aqueous sodium hydroxide? So there's NaOH that is basic, or what you would know as alkaline. So Al2O3 is your amphoteric oxide. You know that it can react with both acid and base. I'm going to show you here because this is an important equation that a lot of students would not be bothered to. It's very easy to write the Al2O3 reacting with acid such as HCl. You simply get AlCO3 plus H2O. So balancing the equation gives me 6 chlorine, so 6 there, 6 hydrogen, so I need 3 there. And that equation is balanced automatically, alright? It is this equation that the other thing where Al2O3 behave with a base, that's the one that a lot of students will not be able to get. Okay, what it actually formed, as you would have known from your paper 3 practical qualitative analysis, this goes back to O level. Okay, and then you also have paper 3 at S level. You know that Al3 plus in aqueous NaOH give you a white precipitate, and then it dissolve in excess NaOH to give you colorless solution. The thing is, have you ever thought about what that is? Okay, you gotta think about it. The white precipitate is aluminium hydroxide. Okay, so it's a neutral species there, meaning to say there is no charge associated with the compound. This species here, the colorless one, is a charged species, and we know that all sodium salts are soluble in water. Guess what? These are all O-level knowledge, and the fact that you know that means that you should know that the salt that you form here is going to be Na plus AlOH form minus. Okay, that is what makes it soluble. And when you count the atoms, it doesn't make sense for you to have water there because you will never be able to balance it if you have water there. You gotta have the water there in order to have equal number of oxygen and hydrogen there. So you have 2 aluminium, I need 2 of that to give me 2 aluminium. 2 Na, therefore I need 2 NaOH. So now I have 3 oxygen plus 2 oxygen, there's 5 oxygen. I have 4 oxygen times 2, I have 8 oxygen. From here I have 5 oxygen, I need 8 oxygen, so I need 3 more oxygen. 3 times 1 plus 5 give me 8 oxygen. How about the hydrogen? 2 hydrogen, 6 hydrogen, 8 hydrogen, 4 hydrogen times 2, 8 hydrogen. So this equation is only balanced when you have the water on the left hand side like that. Okay, so there's a soluble solution, it's not a precipitate, unlike this one where it dissolves in excess NaOH to give you colorless solution, which you have learned from O level actually. So that does dissolve in sodium hydroxide because it can react with both acid and bases. MgO is a basic oxide. It does not react with another base. Okay, so it's not amphoteric, it's just a basic oxide, it doesn't react with a base. SO2 and SiO2 are both what you call acidic oxide. So a lot of people, they just treat inorganic chemistry as a lot of memorization and stuff. But a lot of inorganic chemistry comes down to trends and periodicity. So this is the acid, this is the base. So we are doing an acid-base reaction. So this is not a redox. Therefore, you started with sulfur plus 4 because oxidation state, as you have learned in previous chapter, as well as in O level, you are going to get a salt. The salt must have sulfur plus 4 oxidation state because you cannot change the oxidation state if it is not a redox. It's an acid-base reaction, acid plus base. What you're going to get is the ions will be SO3 2 minus. That is going to be sulfur plus 4. I could show it for you, but you should really know this by now. Overall charge is minus 2, so that's the overall oxidation state. Minus 2 plus 6, that gives me plus 4. Okay. If I have SO3 2 minus, the salt that I get with sodium is Na plus. I need 2 of the Na and 1 of the SO3, And because it's an acid-base reaction, I also produce water, and I need to balance my equation with 2 sodium, 2 oxygen, plus 2 oxygen give me 4 oxygen, 3 plus 1 give me 4, 2 hydrogen, okay? So that equation is balanced there, all right? How about the SiO2, which is option D? SiO2 plus NaOH. Obviously, these are not asked in these MCQ questions, right? But this is what I meant by you can learn a lot from going through multiple choice questions, because it shows how much theory you actually know and how much theory you don't actually know. Okay, so it's very easy to get caught out there. So this is the acidic oxide. What happens is you will get a salt, and the salt that you get with SiO2, carbon, silicon, germanium, blah blah blah, CO32 minus, SiO32 minus. They are going to be similar. You are going to get SiO32 minus. This is called silicate, whereas CO32 minus is called carbonate. Okay, so something you're very familiar with, something you're not very familiar with, but hey, they're just below each other, right? Okay, so if you have SiO32 minus, but then you have it together with sodium, you will need 2 of them because of the lowest common multiple. You need to balance the 2 minus with a plus 1. The LCM is 2, you need 2 of the plus 1. Okay, and here you have hydrogen, so you produce water. This is, you need 2 sodium, and you have 2 hydrogen, you have 4 oxygen, 2 oxygen, 2 oxygen, so 3 plus 1 is 4. And again, you can see this is acid-base reaction. It's a neutralization. It is not a redox. This is silicon plus 4 because the oxygen is minus 2. I hope you can appreciate in Na2SiO3, I can look at the ion or I can look at the whole molecule. If I look at the ion, the overall oxidation state is minus 2. I have 3 oxygen, which is minus 2 there. So that's going to give me plus 4. There's no change in the oxidation number. This is not a redox. This is simply an acid-base reaction. Okay, so the acidic oxide will react with sodium hydroxide in a classic acid-base reaction. So I spent quite a bit of time going through the periodicity here, but I feel that those are essential stuff that will be important to you in the long run, yeah? Especially when you're doing theory paper as well, okay? So it's not just MCQ. So next bit is about the chlorides of period 3 element, your case study. You purify the chloride, then you add the chloride to water. You found it to be neutral. It's got to be sodium. Only sodium chloride give you pH 7. AlCl3 will get hydrolyzed and you get pH 3 or pH 2. It will give you HCl in solution. SiCl4 also will give you, maybe I stick with pH 2. Okay, also HCl. And PCl3 or PCl5 will also give you HCl. All of them are strong acid. They will not be neutral at all. Okay, what is important is you need to try and balance each equation to show what happens when they react with water. Yeah, that is your hydrolysis equations, which typically give you a couple of marks, not just in AS but also in A2. Yeah. So here is continuation of that chloride type of question. They're hydrolyzed by water to form an acidic solution. They talk about its oxide react with acid to form a salt. So therefore can be amphoteric because amphoteric oxide reacts with both acid and bases. So amphoteric oxide can react with acid, or it can be basic oxide. Not acidic oxide because acidic oxide doesn't react with acid. So SiO2 is acidic, so I can forget about that. P4O6 or P4O10 is also acidic, so I can forget about that. Now I can think about the chloride. So MgCl2 is only partially hydrolyzed, such that your pH is very, very weak acid, is only 6.5. But AlCl3 is fully hydrolyzed. You get a pH 2, where you get complete formation of HCl. The chloride is hydrolyzed by water to form acidic solution. Its oxide react with acid to form a salt. Okay, so yes, MgO is basic, But remember, Al2O3 is also amphoteric, so it can react with both acid and bases. Judging by this, I would definitely go for aluminium, because the aluminium trichloride definitely forms a much stronger acidic solution. It's much more certain than this, which sometimes is not even pH 6.5. It could be only very little hydrolysis. Yeah, okay. So this next question is asking you, well, it's telling you you have a mixture of the oxide, you dissolve in water, but the pH is roughly neutral. Either the two oxides react with each other, or the two oxides are insoluble in water, or the two oxides are simply neutral. Okay. The one that I'm circling, this one is insoluble in water. This one is soluble. It will give you MgOH2. Your pH is going to be pH 9, maybe pH 10. Okay, so not very soluble, but still it is alkaline. It's not going to be neutral. Okay, so both of these are basic oxide, so they will dissolve in water. They will give you alkaline pH. So again, B is incorrect. So both of these can dissolve in water. I'm not sure if you know how to write the equation, but in case you don't, you need to. Alright, because this is actually always asked in theory paper, and you have to balance the equation as well. Alright, so that is your basic oxide. P4O10 are your acidic oxide, because when you dissolve P4O10 in water, you are going to get H3PO4. This is your PO4 3 minus. This is your phosphorus plus 5. This is your phosphorus plus 5. Not a redox. Okay, you just dissolve in water. So what happened then is both of these are acidic. So SO3 plus water will give you H2SO3. And this is also sulfur plus 4. This is sulfur plus, oops, I stand corrected. It will give you H2SO4 because you started from SO3, which is sulfur plus 6. That will give you SO4 2 minus, which is sulfur plus 6. Both of these are what you say not redox when you dissolve them in water. Both of these are acidic oxide. Both of them will give you acidic solution, so they will not give you the neutral pH, meaning the answer there must be C. When you write the equations to show the neutralization in water, essentially what you're reacting is you're reacting the NaOH and the H3PO4. But when you're reacting the two oxides together, there's no hydrogen, so we are not going to produce water. But of course, in water, you're going to form this. This is going to form this. This is going to form that. When you have this plus this, it's going to give you the same salt, but it will give you water as well. So the salt that you get is going to be that. It's a sodium salt, so it's a 3 sodium plus in PO4, and the LCM, the lowest common multiple of 2 and 3 is 6, so you need 2 of this and you need 3 of this. Now you have 6 sodium, you have 6 sodium. That's the point of doing LCM, lowest common multiple, primary school mathematics. Alright, I have a problem now. My oxygen is not balanced. I can do half. Okay, so my phosphorus I have 2, my oxygen is 8, so half times 10 over 2 is 5. 5 plus 3 oxygen is going to be 8 oxygen. So this equation is balanced now. Or if you want, you can double the whole thing out. You get 6, you get 1, you get 4, and it's just make the number a lot bigger. Okay, so that is the 4th question. So this is the last question in this video. So this is saying that which of these neutralization could be titrated using the apparatus. So this has to be a solution. This has to be a solution. So we are talking about solution plus solution. All right. Aluminium oxide insoluble in water. You can cross that out. All right. Magnesium oxide, sodium hydroxide, magnesium hydroxide. Okay. So magnesium oxide is not very soluble in water. Remember just now I showed you the equation. it will give you the Mg or H twice, but this is not very soluble. Remember, the hydroxides of group 2 actually become more soluble than group 2, and this is something you will learn in the group 2 subsection in the next topic, I guess. So they are not very suitable because the magnesium oxide, which become the magnesium hydroxide, both of which are not very soluble in water. So they are not going to be suitable for neutralization, because if they don't dissolve fully in solution, how can you ensure that the mole is exactly the same when you dissolve something completely in solution? Okay, that's why it's not a very good method there, because sodium hydroxide, all sodium salts are soluble in water. So even though it's not a salt, but it really helps it to solubilize completely in water. That's why you always do acid-base titration involving sodium hydroxide. So that's the end of this 5 question series, and I'll see you in the next video. If you haven't subscribed, please subscribe to the channel. Like the video if you find the explanations useful at all to you, and share with your network of friends, your colleagues, or your students. Thank you for watching.